right on time. A little bit late. Just working on some technical difficulties. Actually, my internet went out right before the stream started. So, perfect timing internet. Way to go. Alright. Hey, and you may be noticing I'm repping this sweet coffee mug. It says Deb every day. It's a mug that I made to remind me. I've also got the shirt. So I get asked sometimes like, hey, how can I help support the channel? I don't like the idea of like getting something without something in return. Like people have asked me to set up a Patreon. I just, for me personally, that's not the direction I want to take this. But who doesn't love merch, right? And it's a way you can support the channel. So there is some merch in my store. I tried to come up with some stuff that people would actually wear. Some of it's maybe a little bit more weird, but you know, shirts, mugs, stickers, tote bags. Everyone loves tote bags, right? You can never have too many tote bags. But yeah, if you are looking for a way to support the channel, you want to get something back in return, you can buy some merch from the store, and I do get some of the proceeds from each sale. But one of the things that I try to do is I try to do a little work every day. Just incremental progress, you know, put in a little bit of work every day, and then if you do that long enough, eventually you'll get where you want to be. It just takes a little bit of work every day. So I thought of Dev every day just as a reminder, keep working, keep pushing. When I get my coffee in the morning, think about Dev. Really, it's just about building yourself. So that's one way you can support me. Another way, I know I rep this a lot, but if you are looking for some one-on-one time with me to work through some problems, talk about career path, talk about setting up a portfolio, talk about how to better learn game dev, and get to where you want to be, I am offering 60-minute tutoring sessions. You can book that by scanning the QR or going to jimdouglas.com/book-online. You can book a session with me. We could talk about whatever you want. So yeah, it's only $25. It's pretty cheap. I think I might actually raise the price next year. But for now, I'm just going to keep it where it is, because I don't want to price people out of the market. But so that's all the shilling I'm going to do today. So yeah, today's the 27th, right? Yeah, it is. So we're gonna do week 6. You can see these are the previous weeks that we did. If you want to go back and start from the beginning, these recordings are available on my YouTube channel, so you can go back and watch any of these weeks, the past lessons that we've done. This is week 6, so we are, well, after today, we'll be more than 2/3 of the way done, right? We'll be 75% of the way done, hopefully. And this week, we're going to be learning about C++. This is going to be the first time that we've really talked in depth about C++, not that in depth, but talked about it at all. It's also going to be the first time I've ever live streamed a C++ lesson, so that's going to be fun. So bear with me as I struggle through that, trying to make it not boring. Yeah, so we're going to talk about intro to C++ today. Next week, we'll do some more C++ work. It's going to be not so much lessons as it is going to be like how to use blueprints and C++ together. What are some best practices? What are my own personal tips on this? But it's going to be less structured and more like, let's just make some stuff. I have some ideas on what we want to make, and I've already tested that we can make them, but it's not going to be so much like lectures. It's going to be more just like doing stuff. And I'll talk you through my method. And then the last week, it's going to be week 8, launching your game. This again is going to be a little bit less lesson heavy. There's going to be a lot more just like having fun, putting our games together. There will be a few lessons on how to build your game, how to get it, where you can put it once you're done with it. But for the most part, it's just going to be like more just doing creative stuff and trying to get these projects we've been working on ready for release. And here's a list of the topics that we're going to go over today. So the first lesson we're going to start with is an introduction to C++. If you've never used C++ before, you'll learn a little bit about it. If you've never programmed, like written before. You'll learn a little bit about it. C++ is kind of a complex language, which is why for the last 5 weeks we've been doing blueprints. We're trying to build those programming principles, build that foundation of understanding programming, understanding how games are built, and then now when we write the code, it should be a little bit more accessible because you already have like some frame of reference versus just jumping right into C++ and it's your first time ever programming. You're just like, I don't get this at all. This is pretty overwhelming, right? So then we'll talk about a little bit more. We're going to break some of the things down in C++. And then at the end of the lesson, at the end of the week, we're going to build 2 things we've already built in blueprints. So we're going to use that knowledge that we already have built, and we're going to show how to do basically the same thing, but using C++. This is the only part I'm really worried about. We'll see how it goes. There was a question, but I missed it. Would you be able to turn the music down? Is it too loud? Was it that loud? Yeah. I think I just missed I didn't realize the music was so loud. I'm sorry. Could you guys hear me at all? It's like being at a bar and like people are like talking over, trying to yell over the music. Is that how it was? All right, let me go back. I couldn't see the questions because I had it in the wrong screen. So I'm going to read them from this screen. Finally, yeah. All right, and then can we go through the earlier weeks, even if we missed them? No, what? Is it still too loud? Let me switch headphones. I can see it's a little loud still. Let's just do no music today. How's that sound? Now you just get to hear me and my voice. All right, we're off to a good start here, I guess. All right. So the idea is that we've already learned a lot of this stuff in blueprints, and now we can try to apply our knowledge to C++. There was a question, can we go through the earlier weeks, even if we missed them? They are available on my YouTube channel. You can watch the recordings. I leave them all up. And I've tried to, when I have time, put bookmarks in. So like the first 2 or 3 weeks have bookmarks for where each lesson starts, just as like a little helper. And I will eventually get around to doing all of those. I just been stretched a little thin, but yeah. You don't need to start today. Matter of fact, if you start today, it's probably a good lesson if you just want to learn C++, but we are going to be like building on to stuff that we've already built. So if you get a little confused, you might want to go back and watch one of those previous lessons. So without music, let's get started. All right. That may have been the rockiest start of a stream, but don't hold me to that. I think I can do worse. But yeah, if you guys didn't hear me, there's merch. Dev every day. Go buy the merch. It's a way you could support the channel, and you get something in return. Yeah. I don't know if you heard that, so I want to say it again. All right, Introduction to C++. This is week 6, lesson 1. So in this lesson, we're going to define C++. We're going to talk about what it is. We're going to talk about its purpose in Unreal Engine. We're going to describe the difference between a compiled language and an interpreted language. So if you have some programming experience, you probably already know this. But if you don't, we'll explain kind of what's different about C++ and other compiled languages versus an interpreted language like JavaScript. We'll review common C++ resources. So We will be doing some C++ programming in this course, but this is not a C++ course. This is a game dev course where you're learning a little bit of C++. We talk about that in week 1. So if you're more interested in learning about C++ and how it works outside of Unreal Engine, I'll give you some resources at the end of this lesson that you can go to and do some more research. And they are really helpful because I do think it's good to have like a good core fundamental understanding of how C++ is built. It does help you be a better programmer, especially in Unreal Engine, where you're dealing with a game engine where there's millions of lines of code written in C++, and how do you interpret that? We're not going to learn enough in this course to really dig in. This is really just a beginner level course to kind of start building the foundation of your learning so you can go back and learn more after. All right, so what is C++? It's a programming language. You probably already knew that. So it's a high-level, general-purpose programming language. It was created by a Danish computer scientist called Bjarne Stroustrup. And if I said that wrong, I apologize to Bjarne and other people for my American accent. And it was designed with systems programming and embedded resource-constrained software and large systems in mind. So really, what does that mean? Like, okay, I don't work in programming. I don't know what any of those things mean. What it means is that it was built to handle very large programs and very complex systems in a very efficient way. And this makes it ideal for game dev because game dev arguably is one of the most complex ways to learn programming. There's so many things that you need to think about. Resource management is a huge one when people talk about like lag and frame rates and, you know, all of these things. Like, you need a very efficient language. So C++ is perfect for programming, gaming, because it's one of the more efficient languages out there. There are some other game engines that are programmed in C#, Python, JavaScript. If you name a programming language, you can probably find a game engine that's built in that programming language. But a lot of older game engines or like bigger games are usually written in C++ just because of the efficiency. And it's almost always implemented as a compiled language. I have not been able to find any actual instances of it being an interpreted language, but I could be wrong on that. Most of the time, you're going to have to compile it in order for it to work. So what does that mean? Well, a compiled language is when you take the written code that's human readable and you convert it to machine code, which is not human readable. It's binary. It's ones and zeros or hexadecimal information that's a human would never be able to read it. It doesn't make sense to a human, but to a computer, it's like chef's kiss. Like, I know exactly what to do, and then it can execute your code. This is different than an interpreted language. So if you've ever written code in JavaScript, I think Python might also be an interpreted language. The program is executed by a computer program that directly execute it from the code. So it reads your human code and it knows how to interpret that into machine code or code that some other thing can execute. So like a web browser is a interpreter. So you write your code and then your web browser can look at that code and it can carry out the instructions, which is why if you go to any website and you right click and you say view source, you can actually view like under the hood kind of what's going on. A lot of modern web devs like hide their code behind in like a server, and the web browser is just calling functions from the server, so you can't actually see the code, but still the web browser is what is executing the code versus a compiled language where you have an executable that executes the machine code directly. So C++ is a compiled language. Now in Blueprints, we use Unreal Engine as the compiler. And if you remember, whenever we make changes to our project, we hit this little compile button, and that compiles the Blueprints code so that we can run it. You can also use an IDE to compile our code when writing in C++. So you can actually compile in Unreal Engine with your C++. I'll talk about what that means and basically tell you like when you shouldn't use it, my personal opinion. But most of the time we're going to use an IDE to program our code, and we'll talk about IDEs in the next lesson. So when it comes to Unreal Engine source code is actually written in C++. There are some other languages like sprinkled in there, but a vast majority of it is actually C++. And then all of the classes are derived from C++ classes. This includes the blueprints classes. They originate from a C++ class. It's called UObject. And even the editor itself is written in C++. I don't know as much about that, but if you wanted to change things about the editor, you could actually do that and change the way the Unreal Engine editor functions. New classes can be created as C++ classes, and we'll talk about that in a couple lessons, but you can create a C++ class and write some C++ code, and then you can make it into a blueprint class. You can also create a custom class from a C++ class. So if you wanted to take the character class, and so far we've taken the character class and we've made a blueprint from it, but you can actually take the character class and make a C++ class that inherits from character and then write your code that way. So all of this can be done. Basically everything we've done so far in this course, for the most part, can be done in C++. There are some exceptions, but for the most part, most of the stuff you can do can be done in C++. So again, like I said at the beginning, we're not going to go like super in depth into C++. We're going to learn some basics as it pertains to Unreal Engine and as it pertains to game dev. But if you want to learn more about it, these are some great references. I actually have all these pulled up so I can... So the first one is this W3 Schools C++ tutorial. If you go through this, you'll actually learn a decent amount. It gives you some exercises to work through. It's going to, it like goes through all this. So you kind of like learn a little bit as you go. I think this is a great resource for learning like how things are done. And there is some why in here, and there's a lot of other like resources here. Like if you just go to C++, there's all this stuff that you can use. So this is a great resource if you just want to like learn a little bit. Matter of fact, if you search something on Google or something, this is probably going to be one of the things that come up if you're asking like a basic C++ question. There's this one called learncpp.com. This is a great tool that I've used in the past. It gets a little bit more into the why, which is a reason why I like it. But there's some good tutorials on here, and it tells you a little bit more about like why you're doing what you're doing, which is something that I typically like to lean for. I don't like to just know how to do something. I want to understand why it works so I can apply that knowledge going forward. And that's how you get out of that tutorial loop. You need to understand the why. There's cppreference.com. This is a great reference site. There's so much here. I use this from time to time, like I'm just trying to understand something. Notice that there's like a CPP version here. So there are actually different versions of C++. So it is something you need to be aware of. And as time goes on, they add more and more. I do believe, I could be wrong, and this is probably easily Googleable if you want to fact check me, but I think Unreal Engine uses C++ 17, but I could be wrong in that. They may have moved to 20, so we'll see. Then there's Mr. Strausstrup's page himself. This is strausstrup.com. There are some really cool tutorials on here, some basic information, but also it's a great place. He's written like several books over time. These are great if you want to learn more about C++. I recommend this one if you want to start. It's called Programming Principles and Practice Using C++. I think you can buy a hardcover or a ebook. So if you really want to learn C++, I think this is a great place. And if you buy this, it also can be used. It's a very useful reference. So just some resources that you can use in your journey to learn C++. So with that, let's go to the next lesson. So as I said, we are going to be needing an IDE to use C++ with Unreal Engine. So this is lesson 2, installing an IDE. In this lesson, we're going to describe the purpose of an integrated development environment, or IDE. We're going to describe some common IDEs used with C++ and Unreal Engine. And spoiler, we're using Visual Studio Community 2022 for this course. And we'll talk about why. So at the end of this, we'll talk about how to install that. So what's the purpose of an IDE? You've probably seen something similar to what's shown on the right side of the screen, but it's a software application that provides facilities for software development. It's basically a place to put your code. Technically speaking, Notepad can be used to write code, but one of the things in like most code is just like a text file. But with a language like C++, you need a compiler. You need something that's going to build it into a program. So you could actually program in like an interpreted language like JavaScript using just Notepad, like literally Notepad on your computer. You can just write it as a text file. But with C++, we need something to make it into that machine code. So you're going to need an IDE. So, like I said, these typically provide a lot of extra features: authoring, monitoring, modifying, compiling, deploying, debugging. These are all usually built into most modern IDEs. Some are dedicated to a specific language, but most of the modern ones can be used for a variety of languages. It's becoming less common to see one that's like built just for one thing. Most of the time you can use a lot of different programming languages, and the modern ones usually have like toolkits that help when you're learning a programming language. So like I said, it's different from a text editor. A text editor can be used. There are text editors like Notepad++. There's one that I used to use a lot that I can't remember the name of right now when I was doing JavaScript coding. So there are some of them, but when it comes to compiling and building your code, you're going to need some extra features. So you're going to need an IDE in most cases. So here are kind of like the most common ones that I see used for Unreal Engine, and we'll talk through each of them. So VS Code is like a very lightweight IDE that can be used. You can technically use it with C++ and Unreal Engine. I typically like to use VS Code for other programming languages. It's actually my preferred IDE for everything but Unreal Engine. When it comes to using it for Unreal Engine, I have had issues in the past. I may use it in a pinch, but for the most part, I stay away from it for Unreal Engine, but I use it like literally for everything else. And mainly it comes down to the compiling. I've had issues where the compiling doesn't always work correctly. So that's my reasoning for typically staying away from that one. There's also Rider. This actually started as like an extension for Visual Studio Community, and then they made their own IDE. Rider is actually really good. A lot of people just straight up say it's the only thing you should use for Unreal Engine. Whenever I have an issue with Visual Studio Community and I'm on the forums or I'm asking for help, the answer is almost always like, well, why don't you just use Rider? You wouldn't have this problem. And to be honest, the only reason I don't is because it's not free. You have to pay for it, and it's not insignificant. It's like $20 a month or something. If you're going to be doing programming full time, I do recommend probably just forking out the $20 a month for this. But if this is a side hobby or just something you're doing for fun as like a personal challenge to yourself, it might not be worth that $20 a month, especially when you're just learning, because you're not going to be able to have a return on that investment for a while. But in most cases, it is probably better. For this course, we're not going to use it because I want to make sure that things are accessible to people. So we're going to be learning on Visual Studio Community because it's free. And if you want after the course to go use Writer, check it out. There's plenty of tutorials that use it. I think actually all of Stephen Ulibarri's courses use it. So if you're watching one of his courses, you're probably seeing him programming using Writer. And then there's Visual Studio Community. So like I said, if I'm programming in any other programming language, I use VS Code. When it comes to Unreal Engine or C++, I use Visual Studio Community just because I haven't really had any issues with it. The issues that I have found are mostly user error or just I didn't set it up correctly or something. And very rarely do you run into an issue where you can't use it. And in those cases, I'm going to show you some of my workarounds that usually resolve any issues that I've had. So we're not going to use VS Code because I've had issues with Unreal Engine. We're not going to use Writer because it's not free, although it is likely a better solution. We want to use free stuff for this course. And we will be using Visual Studio Community. So let's talk through how to get Visual Studio Community on your computer. So we're going to start by going to a website, visualstudio.microsoft.com/vs/community. If you just Google Visual Studio Community, you'll end up in the same place. You're just going to click download and install. Yeah, there it's downloading. And then when you click this exe, I already have it installed, so it's going to do something different. But yeah. Oh, why? I don't know why it's down. But anyway, it's already installed, dude. Anyway, if you open it, once it opens, I do want to show you this next step. I didn't think it was going to do this. I guess I should have tested it before the stream. Here we go. This is the Visual Studio installer. So you would find the version that you want to install. I already have Visual Studio Community 2022, but if you go here, you can see other ones. You can also find older versions. But yeah. So you'll want to install it. Just so you know, I did this ahead of time because it takes like a long time, like longer than I thought it would. You're installing, like, it's a pretty big program. But one of the things I want to let you know is eventually you're going to get to this page, and it's going to ask you basically what it's asking you is essentially like, what do you intend to use this for? Because we can install some stuff that's going to help you. So you can see if we're doing Python or Node.js, mobile development, C++, like there's a variety of tools here. There's Unity, there's game development with C++, and we can see use powered by DirectX, Unreal Engine, and then this Cocos 2D thing. I'm not sure what that is. But basically we want to select some of these packages, and it's going to install them onto our computer, and it's going to allow Visual Studio to work. Yeah, sorry. But yeah, they're all the recordings are available. So it's a lot. I think it's like, last I checked, it was, I think I actually have it open here. It's like over 12 hours of recordings at this point. At some point when I'm done with the course, I'll probably like edit them down so it's not like you're not just watching me like trying to troubleshoot, and I may even edit them down into individual like lesson videos. So we'll see how that goes. But for now, I've just been trying to keep up with the course and not have to push out lessons too much. So we do want to click this one, Universal Windows Platform Development. This is going to install some of the stuff. I think we also need this one technically because there's some .NET stuff in Unreal Engine. We definitely want this one. It's going to give us a lot of the tools that we need. It's also going to set up to do the compiling directly to Unreal Engine. And then there's some other ones that we want. So these Windows SDKs, one of these, I think it's this most recent one, you're going to need that. This is what's going to set up so that it recognizes that you're trying to use Unreal Engine, and it'll set up some helpers to basically tell you like when you're doing something correctly. I also do these ones because there's some stuff in there, but I don't think you have to. And if you're using Windows 11, you'll want to select that one as well. And one of the things you might also want is GitHub Copilot. If you want to use that, this is also not free, but I've found this is well worth the $10 a month. I think it is. It gives you some helpers. It kind of tells you when you're making a mistake. You can ask it questions, but it's not free, so don't use it if you don't want to. But if you are going to pay for some AI tools, it's probably one of the ones that's the most worth your time. So you'll just so you can I'll show you. If we select this one, it's going to start installing all of these onto your computer. And I gotta close it. Oh no. I was trying to get the next lesson ready and I forgot to save it. But anyway, it's going to install all those. Again, this is going to take a while. I tried to do it ahead of time because I didn't want this 4-hour stream to be 2 hours of watching me have software installed, but just to show you can make updates to the IDE. There's also a page. If we go to set up Visual Studio for Unreal Engine, there's this this one. So I'll actually just put this straight into the chat. I don't know if anybody's watching on Twitch, but we'll throw it on there too. This is this just walks you through. It's actually on the Unreal Engine docs, and it walks you through how to set everything up. It kind of just goes through what I already did. So it talks about installing these. This part you can probably ignore, but if you want to, you can. I feel like it's weird because this one feels like personal preference stuff, but whatever. But yeah, I recommend just follow along with it exactly, even though some of the stuff isn't really required. But this will get you set up for installing Unreal Engine. Matter of fact, every time I've had issues with Visual Studio Community, and then I go back and I uninstall it and I follow this, it resolves all my issues. So I just recommend just go to this. If you've never used it before, just use this. It's probably the best. So yeah, here we are. It's installed. It's up to date. And that's it. That's all you have to do to install Visual Studio Community. So do that. And then if you're watching the recording, come back. But right now, we're going to go to the next lesson. No, you don't have to reinstall it, but you do want to make sure that you have those extensions or those plugins or whatever they're called installed. So, lesson 3, 30 minutes in, not bad. Look at this cool mug. You can get one on my store. And a shirt to match. Man, am I being too much of a shill? Anyway. All right, so this is week 6, lesson 3, elements of a C++ function. And this lesson, we're going to convert our action RPG game that we made, that we got started in week 5, to a C++ project. So I'll show you how to do that. We're going to describe the elements of a C++ function, and then we'll review some common blueprints functions, or basically just talk through like how we would set some of those up, some of the things we've already done. So let's convert our project to a C++ project. So here I am. I'm going to open this action RPG game that we got started in week 5. All right, here we are. And up until this point, we've been doing everything in Blueprint. So this is going to be like the first time we actually see C++. And I'll show you basically how we convert a game to a C++ project. And when you are setting up a new project, there's an option. Okay. Anyway, there's an option to set up a project as a C++ project. And you can do that, especially if you, as you get to know a little bit more, you may be comfortable doing it that way. I do want to warn you that if you do that, all of these actions that are set up on your character by default, so like these input actions and everything, they won't be set up in Blueprints. It'll be set up in C++. And if you're comfortable with that, then go for it. When you're starting, I do find that like using inputs is one of the, it's not like super complex, but it's a little bit harder to grasp when you're first learning C++. So what I usually recommend is that you still build it as a Blueprint project, so you have access to like these events. And then you can convert it to a C++ and do just the things that you want to do in C++. So essentially what we do is we start here, we're in Unreal Engine, and it's actually pretty simple. We just go to Tools, and we want to create a new C++ class. And this menu looks pretty similar to one that we've already seen. This is asking us, what class do you want it to be derived from? What do you want it to inherit from? So we got some of the ones that we've used before: character, pawn, actor, actor component, things that we've already talked through. You can also go to all classes and you can see all of them. I think there's even some that aren't accessible as blueprints here, but just to keep things simple in the start, I'm going to create a new actor class, and I'm going to go to next. And this is going to ask me, what do I want? Do I want it to be public or private? And notice when we do this, the only thing that really changes is that these two files that it's going to create, it's changing where is it putting them. So in most cases, I like to set them up as public because you're going to want to have some things public and some things private. So doing it this way sets up the header file, which we'll talk about in the next lesson, in the public file, so that way everything can access it, and then the private folder is where it'll put the CPP file, which we'll also talk about. I'm going to name this CPP intro. We'll just call this, and we can see now, so we've named our class that we want to set up. This is going to be an actor, and you can see it's going to create two new files, a header file and a C++ file. This is something that is used in C++, and we'll talk about what this is. And then I'm going to say create class. And now what it's actually doing is it's taking my Blueprint project and it's making it a C++ project. So we have access to all that underlying stuff that we would normally not have access to. So this sometimes can take a bit. We'll give it some time. And then it's telling us that we need to close it and build it from our IDE. So let's open up Microsoft Visual Studio, and it's going to open it for us automatically. This is one good thing that I love about Unreal Engine, is it recognizes it that we want now to go to the IDE environment, and it'll just open it for us. And here we are. Look at all this. So there's a lot to absorb here, and we'll try to break things down a little bit as we go. But if you've never used Visual Studio before, you've never done text programming before, I'm going to try my best to break things down, but it's also like one of these errors of like when you understand something, you tend to forget what you don't know, or what you didn't know in the beginning. So I'll try to do my best. But essentially what we have, if we start at the top, we have some menus, typical to most Windows-based programs. So here we can create new files, new projects. We can open files and projects. This actually links to GitHub. So we learned about repositories in week 5 and how to set up source control. So you can actually use this to manage your source control as well. GitHub is owned by Microsoft, so they all work together. But I think it does also work for other Git solutions as well. You can set this up to interface with your other source control systems. Here we can see some Git functions. So fetch, pull, push, sync. All the Git functions that we talked about in week 5 are available through here. Project, we have some settings about projects. Here we can see we can add a class from here. We can do a lot of stuff. Build, we'll talk about this, I think, in 2 lessons, but what does it mean to build a project? Some debug functions. A lot of this stuff I'm not really going to get into, but you can, dig around in here. You can probably find some other tutorials. I think Microsoft actually has a pretty good YouTube channel that they have some tutorials on how to use all these. So probably just go there. This is not a Visual Studio tutorial, so I'll stick to just kind of what we need. Also, we can see directly below that, it's telling us how to, like, some information. It tells us the name of our game. These are the tools that it's going to be using for this solution, and when we start building our project. So these should look like this. If you set up Visual Studio correctly, it should look like this. If not, and they look differently, you might want to go back and watch one of those tutorials on how to set it up. But this is what's going to allow us to have Visual Studio and Unreal Engine kind of talking to each other. In the middle here, we see we have our code. So we have 2 files that we made that it opened up for us: cpp intro .cpp, which is the C++ file where we write our code, and then the header file. We'll talk about this in the next lesson, but just know that there are 2 files that it created when we made a new class. Over here, we have a Solution Explorer. So this is giving us access to all of the different parts of our project. We can see we can actually dig in to the Unreal Engine itself here. So if you want to go look at the source code and you download it, this is when you download Unreal Engine, you have to select download source code, but you can go through here and you can actually look under the hood of how Unreal Engine works. If you're just starting out, this is probably going to be very overwhelming for you. And understand that, like, once we start doing this, the training wheels are kind of off. So if you're going to be doing this in C++, I recommend 2 things. 1, don't change anything unless you really understand what you're doing. And 2, if you do want to change things, make sure you're using source control and that you have your project set up so that if you break something, you can revert back. Especially when you're starting out, I highly recommend source control first, which is why we did it last week, so you know what to do and you can set up all your projects on source control and have them backed up. And then if you break something, you can revert back. So that's my suggestions. And then here we can see actually our game, Action RPG, and we can drop this down and we can see all the information that we had. We can see our get files, get ignore. We can actually read it through here, get attributes. We can actually read it here and see here where we set it up for LFS. We can go to our source code. There's some files here that you can look through. If you may end up needing to change these at some point, but like for instance, this one, actionrpg.u project. If you're setting up some plugins, you'll actually need to like make changes to this. You can see here it shows what version of Unreal Engine we're using. There's also some other stuff it'll do. So this is kind of a basics of how these are set up in Unreal Engine. We can also see that we have a public and a private folder, and right now there's only two things in there. So this public folder holds our cpp intro.h, and our private folder holds our cpp intro.cpp. And these are kind of like the basics of whenever we set up an actor. You can see that there's some information already in here, but the information in here looks familiar to us. If you've been following along and you have a little bit of experience in blueprints, we can see that we have some, these are functions being called, and on the header file, they're declarations. So let's break this down a little bit more. I think that's the end of this lesson. Let me just verify that. No, it's not. All right. So we did have, we have these functions that are being declared. So let's break down what is in, we have these functions here. So let's break down what is in a C++ function. So I'm actually going to go back to my lesson, and we're going to talk about the elements of a C++ function. All right, there we are. So up until this point, we've been doing everything through blueprints, but blueprints are essentially C++. It really is just like making every node is just a snippet of C++ programming under the hood. So if we take this function at the bottom that we've set up in the last two lessons, the last two courses, we have a function. It's called SumFunction, and man, you really can't see that with my head there. Let's just turn the camera off for a second. We have a function called SumFunction, and it has an input variable called damage. We're taking a variable called current health, and we're subtracting damage from it, and then we're setting current health. And then we want to check if current health is 0. If it is, we'll return is dead. And if it is not, we will return false for is dead. So the function above, written in C++, is essentially the exact same thing. So let's break it down. So we have a class variable that's being declared. It's called an int, and it is called current health, and we're setting that as 100. And we can see down at the bottom we also have a class variable called current health. This is our function declaration. So all of this in these brackets here is the function. Now const is just a way to declare that a function is not is going to remain constant. The bool here is how we pass in an output variable. So we're saying that in this function, we want to return a Boolean. We want to return true or false. Then we have the name of the function with some parentheses, and that is how we declare a function. We name the function, and then some parentheses, and these parentheses can be 0. That means that we have no inputs. We just want this function to run, and there's no input required. But if we do want an input, we declare every variable that we want to input, and these would be, if there's multiples, you separate them by a common. So if we had another one, we would write a comma, and then declare our next variable, and you can declare as many as you need. Then we have some curly brackets, one that opens it, one that closes it, and then it's followed by a semicolon. Now here we're declaring a local variable within this function called isDead. And we then take current health, which is this class variable. We subtract from current health the damage, which is the variable that we passed in. And so that's going to set current health. So up until this point, we've done everything up to here. So the whole left side of this function. Then we want to check if current health, so an if statement is used. So you can see this is fairly human readable. So if current health is less than or equal to 0, then we have some new brackets that open up an if statement. So this is going to be the if true. Then we will set isDead to true. And then we have an else statement that says, so if this part is true, or if current health is less than or equal to 0, do this top part. If it's not, do this bottom part. So we set isDead to false. And then right at the very end of the function, we have a return variable that we declared up here. So we had to declare that we want to return something, and then we are returning something. We're returning the status of isDead. And it's pretty smart. It'll check you if you do things incorrectly. It's actually going to tell you that you set the wrong variable. So we're returning true or false, and this function at the top is identical to the blueprint function that we've already written a couple times in this course. So kind of a lot to absorb there. If this is your first time seeing it, yeah, I recommend that everything we do in this course we're going to break down, but if this is completely overwhelming for you, I recommend going and reading some of those resources on C++. But for the most part, I think this is fairly human readable, and we can continue to build upon this knowledge. But I just want to show you how you would convert your knowledge of blueprints into a C++ function. Creating a C++ class, we already did that, and I think that's the end of this lesson. Yes. So let's turn the camera back on. Here we are. All right. So let's do, the next one is going to be on the header file. Let's turn this camera back on. Here we are. And looks like we're doing good on time. This is great. Might even finish early. So let's talk about what the header file is. When we made that class, it made two different files for us. It made a cpp intro.h and a cpp intro.cpp. Probably could have come up with a better name for it because it's confusing me. So in lesson 4, we're going to talk about what that header file is. So we'll explain the purpose of the header file as it relates to Unreal Engine, really C++, but specifically Unreal Engine. And then we're going to define a few things that we're going to see commonly in our header files. We'll talk about what a U function is, what a U property is, and then we'll explain the #include, #include at the top. So what is the purpose of header file? So the header file establishes functions and variables that belong to a class. And really what that means is it gives the compiler instructions on what is in the class. So that this is actually one of the things that makes C++ so efficient, is that the header file like compiles everything and gives the program like very easily instructions on how to gain access to things. It gives a class access to functions and variables from other classes, so you can reuse code by declaring things in header files. And then Unreal Engine has a variety of built-in macros that we can use in our header files. So U class declares a class that inherits from a U object. We can see it here, U class. U property and U function are how we declare properties, or variables and functions. So a little bit about the U function. So this allows C++ functions to be called in blueprints. So we can actually create a C++ function where all the functionality is included in C++, but we can create it, we can make it accessible in blueprints as a node so that you can call that node in your blueprint, but it would run the C++ code. And this ultimately, as we'll learn next week, is what makes Unreal Engine so amazing, is allowing that flexibility and allowing you to use both a written programming language like C++ that is very efficient, and blueprints, which is a visual scripting language that is great for people that don't have as much experience in programming. You really allow that flexibility when you're creating your games. So the U function is what allows it to be, what allows the function to be seen by blueprints. There's also the specifiers that control how the function behaves in the editor. So we can have a specifier called blueprint callable that allows us to call that function from blueprints. We could have a blueprint pure. There's many of these. I included a resource down here at the bottom. This resource is in a lot of ways better than the Unreal Engine documentation. There are function specifiers and metadata specifiers that exist in Unreal Engine that don't exist in the Unreal Engine documentation. So this person, Ben UI, actually just created his own reference, and I find this one's actually better. So I can put the link for this, but yeah, I'll give a link once we get through the rest of these slides. All right, U property, so similar to U function where we're declaring functions, U properties is how we declare properties or variables as we call them in blueprints. So this controls how a property behaves with various aspects of the engine and the editor. So this is how we can tell Unreal Engine what a programmer or designer should be able to do with a function. Now, we talked a little bit about object-oriented behavior and encapsulation and abstraction and all these various like principles of object-oriented programming. C++, we're really gonna have a lot more access because you can actually create functionality in C++ that runs under the hood, but a person doing design work or programming in Unreal Engine blueprints won't even know it exists. And you can really control what they can see and what they can't. So in a game company where you're working with a team, you may have strict rules about what should and shouldn't be accessible. And there's really two very different skill sets. So they want to focus more, like programmers would do the C++ programming, and designers or tech artists would be doing the blueprints programming. I also just realized that I started an hour early without even like actually realizing. So we're actually gonna end up like quite early, which is funny that because I just got a notification from Discord that's like, hey, your event's starting. I'm like, I started an hour ago, and then I remembered I was supposed to start at 10. Oops. Hey, if you're just getting here, you missed the first hour. I'm very sorry, but you didn't actually miss much. You can always go back and watch it. Again, this Ben UI guy, great resources for learning this stuff. I'd highly recommend going to this and reading his documentation. All right, and the last thing we need to talk about is the include file. So what this essentially does is it allows a C++ class to reference functions from another C++ class or to reference another class. And then anything that's in the header file can be accessed by that other class. So again, this is where having like things in your header file or your CPP file allows that differentiation of who can access things. You can create functionality on a C++ class that is only visible to that class and nothing else can see it. And this really allows that extra level of protection when we talk about encapsulation and abstraction. It really allows you to hammer down like controlling what information can be passed between classes. So really good programmers on large teams are going to have, again, very strict rules about what goes in the include file and what people would have access to. So yeah. Now, there is a note here that I put because I've made this error way too many times. So when we create a class in Unreal Engine, there's this include, and that's going to say the name of the class .generated.h. This always needs to be the last line. So if you're going to do additional includes and you put them below this, it'll actually break the compiler and the compiler won't know what to do with it. So make sure that's always the last one. I've made this error more times than I can count. So that's my advice there. So let's talk about some header file changes. So we're back here. And I think this is something I forgot to say, but a really good way to think about like what's the difference between the header file and the C++ file is to look at a blueprint class. So if you notice, everything over here on the right, we have functions, variables, macros, event dispatchers. It actually interfaces shows up here if you have an interface. All of these are in this My Blueprint tab. And we have all of our components up here. So if we think of this left side of the screen with the components and the My Blueprint, everything being declared, this is actually like in a way the header file of a blueprint. It's declaring like what is in this blueprint. And then all of this stuff over here is what does it do? So we declare this IA jump, right? And then the event graph says what happens when we call IA jump. Similarly, if we have a function, this class luckily doesn't have any, so it's terrible for this example. But if I were to declare a function called my function, I'm declaring the function here, but this is actually like what happens when I declare the function. So in a way, everything over here on the left is your header file, and everything here is your CPP file. And I think included in that would be this details panel, I guess would fall into the realm of the header file. So yeah. But yes, so we got, so that's how that works. When it comes to C++, we're going to declare things in our header file, and then we will control functionality in the CPP file. So let's just declare something really quick. And I'm going to declare that this in the public function. I'm going to type a variable. I'll just call this test. We need to declare the type, so I'll call it an int32, and I'm going to call this test variable, and that's declaring the function. Oh, it's got to be all one word. And if we use that u property specifier, oops. Thank you, GitHub, for saving me some time. We have our uProperty macro that we declared here, and we can have various things. So right now we have edit anywhere, we have blueprint read write, and we have this category, which I will delete because I don't want that. And so now I've declared a new variable. If I save this file, and for now I'm just going to use hot compile, but I'll show you what that does. Down here, where is it? Oh man, I think I need to reopen. I'll just do it here. We're gonna discuss this in a future lesson, but right now I'm compiling. We'll talk about it in a future lesson. As you can see, it's very slow. The compiling times are significantly longer. And there are some reasons for that we'll discuss, but I just want to show for now that we can access this variable in blueprints. Actually, let's just go to the next lesson while that's doing that. We'll have plenty of time to show this, because right now the next lesson is actually compiling. So it's probably a good time to segue, and then we'll go back and we'll talk about the header file changes. So this is lesson 5, compiling and building UE5 projects. In this lesson, we'll demonstrate building UE5 project files in Visual Studio. We'll describe live coding and what that means, and the advantages and disadvantages, or limitations, I guess I should say. And then we'll demonstrate compiling in live coding. So essentially what I've just done is I did a build. I've compiled my project. So I made a change to my header file, but in order for those changes to be visible in Unreal Engine, I actually need to compile the project, and then that will allow any changes that I've made to be visible through Unreal Engine, because this is like what's under the hood of Unreal Engine. So the way, if you've set it up correctly, is we'll go to build and then build action RPG. It's also Control B is the hotkey, and you'll see down here it was doing all these things. So this is giving you information about the build. It'll show you what classes were being built during that time. So we can see here we built action RPG.cpp. We built our library files, and the CPP intro we built as well. And then it'll give you some information after it's done. I think that might be a little too small. Settings. Anyway, I'll figure out how to make the text bigger, I guess. But it's going to give you some information. So it says build 12 succeeded, 0 failed. So it's basically telling me that everything worked. And then we can go back and open up our project by clicking U project, or going to the Epic launcher, or there's actually built into Visual Studio, if you set everything correctly, we can use this debugger, and we can actually open up Unreal Engine this way. Now, I will tell you, there are times when I use the debugging tools. If I'm debugging or actually like trying to get something working, I'll actually use this, because it's running Unreal Engine in a way where Visual Studio is actually what's running it, and it's going to give you some information about like what's going on with it. It'll give you some extra logs information, so you can see all that directly through Visual Studio. So if I'm troubleshooting something, can't really figure out why it's not working, a lot of times I'll do it this way. If I'm actually like trying to work on my game, I don't typically do the debugging mode, because I want to like work on the game itself, and I'm not so interested in like troubleshooting. But it is there if you want to use it. I don't think there's any reason like not to use it all the time. I think it's probably just personal preference. But yeah. So we have this class that we called CPP intro. I can actually now, in my blueprints folder, I can right click, and when I go to blueprint class and I type CPP intro, I can actually create a blueprint from this class. And if I select it, I can call it BP intro. And now I have a blueprint that derives from my parent class CPP intro. And when I click on this, it'll go to the class in Visual Studio. So this is very useful. So now this is the first time, and I think we actually are going to talk about this in a future lesson, but that is essentially how you create a blueprint from a CPP class. You can also, if you find, so down here in our file explorer, now there's going to be CPP classes. We can go to our public folder and we can see that we have our CPP intro C++ class. I guess my head's kind of in the way, but yeah, there it is. You can right click on this and say create blueprint based upon this, and then you just need to tell it where you want it to go. But they essentially do the same thing. And if we look here, we can see that we have a test variable that we set up, and it's able to be changed, so I can set it to something on this class. And I can also, on begin play, I can get access, so I can say get test variable, and we can see that it's an integer because I declared it as an integer. And I can put one of these into my game, and when I play, it's going to print 10. I can show you that if I change that variable to 100,000 and hit compile, press play, now it's printing 100,000. So we declared a variable in C++, and we can access it through blueprints. And because of the way that we set it up, we can actually change that value. We can set test variable and do it like this. So we could set it to 500, and now it's going to print 500 instead because we set it and then printed what the value is. So you can see already, hopefully, some of the flexibility that using C++ and blueprints together really is going to help you. Notice though that down here, in the variables, this doesn't exist. Test variable does not show up here. That's because it's a variable that is declared in C++. We can go to class defaults and we can see it here though. And if we were to change the category, it would go into a different category over here. So that's what that category does. We can revert it, and it's going to revert it back to 0. And why it reverted to 0? Because we didn't declare like a default value for it. So the way to do that is I think you can declare it here. I don't see why you couldn't. 10. It might stop me. Or you can declare it here. So when we look at our CPP file, we see that we have a few things that should look familiar. We have this tick function, so we could put functionality in our tick. We have this begin play function, and we can put functionality in begin play here. Notice that there's this super. This is something we want to keep in there. What it's saying is that whatever class this inherits from, then we want to call begin play on that as well. So we would, in most cases, wanted to keep this and then put our functionality below it. But if there could be a situation where you wanted to do something first and then call the begin play on like the overarching class, you could put it above it. Note that in C++, it's going to call things in the order that they are here. So if you do something above this and then there's this, it's going to do it one way. So like for instance, if I type test variable equals 10, and then I do test variable equals 20, it's going to set test variable to 10, and then it's going to set it to 20, which means it's going to be 20. Also here, know that this, becomes that super. So it's going to set it to 10, then it's going to call this, which is going to call this. So it'll set it to 500 and then print 500, and then it'll be set to 20. So that's just some knowledge on how that should work. But typically there are cases where you may want to declare a starting value in your header file. If I can't think of any reason right now, but I'm sure there are. Most of the time we want to declare it here. And this is something that is different to us. So this is called the constructor. This is basically saying when this class, like even before we start to play the game, we want to do some things to this class that construct it. If you've ever noticed, like there's always this that we've never used, which is a construction script. So you can actually set up similar functionality here in this construction script, but we've never used it because I think it makes more sense when you look at it from a C++ aspect. So what this says is this is always going to be the name of the class : and then the name of the class as a function. And we can see this is also on our header file. And it tells us right here, sets default values for this actor's properties. So we don't really want to set a default value here. We want to set it in the constructor. And I'm just going to show you really quick what happens. So let's take this test variable here, and let's put it here instead. So we want to set it to 20. And what this says is that the base value of test variable should be 20 because we're putting it in the constructor. We can also set up like functionality for this actor. Do we want to use tick, true or false? There's like a bunch of things we can call in the constructor. So let's do test variable 20, and we're going to use we're going to stop our debugging. We're going to save everything. Control Shift S saves all. Then I'll do another build. Yeah. Oh, and then we see we have a successful build. So if you're just joining me, we're learning C++ today. Just the basics. So we built our project. Now we can use the debugger again. It's going to open Unreal Engine. I will say, you're going to realize really quick when you start using C++ how much it, like if you're used to blueprints and you do this, it's going to feel painfully slow because of having to compile it and then reopen the editor every time. So let's now go to that blueprint that we made. I guess it didn't save it. Class CPP intro. VP_intro. I wonder if that was because we were in debugger. And now we can see that it's at 20 because we set it in the constructor. So this is basically saying the default value of test variable should be 20, and we can see that it's 20 here. We can now, I'm just going to delete these. We can print get test variable. Let's set it. So we should print 20 and then print 500. Let's see what happens. Oh, got to put one in the game. Oh, it printed 10. And I think that's because I think I knew that was going to happen. Yes, I did. I promise I knew that was going to happen. I did that for a purpose. So look here. It set it as 10, which means even though the default value is 20, where is that? Here, we set it as 10 and then we called begin play. So then it's going to call this and it's going to print it, but it's not going to print 20, it's going to print 10 because we set it before this begin play. Then we set it to 500 and then we printed it and then it's 500. So that's why we got that behavior. I knew that was going to happen, I promise. So it prints 10 and then 500. If we were to remove that line here, save all. I'm going to use the hot compile. We'll talk about this, I think, in the next lesson. And we got a green. So now it prints 20 and then 500 because we're not setting it before begin play. If we were to put test variable equals 10 here, then what's going to happen is the default value is 20, right? But we begin play, so it calls super begin play. It's going to call this. It's going to print 20. Then it's going to set it to 500. It's going to print 500. And then it's going to call this line to set it to 10. And now it's 10. So just so you know, like, just be aware of the order that things are happening. And so you can see there that I was doing some changing. I want to show you another quick thing, and then we'll go to the next lesson. But in my header file, I have this edit anywhere, and I have this blueprint read write. If I change this to say blueprint read only, this might break my game, so I'm actually going to close this. And then I'm going to build. This might actually break things. I probably should have tested this before I did it. I might actually get an error here, a build error. No, I didn't. All right, let's see what happens. So I got asked early to turn the music down, and I just turned it off. If you've been watching before, do we like it without the music? Oh man, I opened the wrong one. No. Oh, I did. I usually have music, but some people say it's distracting. I don't know. I think if I was ever going to edit these down to like individual videos, it's probably better to not have the music. Let's open this. And look at that. We have an error. So we originally had this set up as blueprint read write, and then I changed it to blueprint read only. And now it's actually giving me an error. And it says this is not writable. So I can't set it. But notice I can still access it. I can still get the variable, but it's not letting me set it. So now if I do set test variable, it doesn't even pull up because I've actually removed the ability to change it in Blueprints. So that's the power of these macros, is it really allows you to like change information or change the access information. Let's compile and save this. And I want to show one other functionality. I'm going to have to close this again. Let's change this to say just visible anywhere. Save, build, Control B is to build if you're using Visual Studio. Succeeded. Let's launch it again. Very slow, I know, but I'm trying to demonstrate a point really quickly. And then I think there we are. So now look, when I go to class defaults, I can see that variable, test variable 20. I can access it, so I can read from it in Blueprints, but I can't actually change it. It will not let me change the variable. So this could be good if you wanted your designers to see like what something is, but you didn't want them to have access to change it. And then you could set up the ability to change it in your C++ class. You know, if there was let's say this was health, right? Let's just say it was health. And you want the designers to have access to change the health. You can create a function that is accessible where they can pass in a variable and that becomes the new health. And then in your C++, you could handle the changing of the health, but they wouldn't have access to change it, to change the variable directly through Blueprints. They'd have to call a function that could change the variable. So if you are working on a bigger team and you want to have things separated by skill set, you could always do it this way. So just so you know. Now I do want to show one more thing, and then we're going to talk. It's kind of a segue into live coding. So let's change this back to edit anywhere, and let's change this to blueprint read write. And I'm going to hit save, and now there's actually this thing, and I kind of previewed it. So down on the bottom, this thing, and if we hover over it, it says recompiles and reloads C++ code for game systems on the fly. And I can select this, and we get this live coding window. So this is sometimes referred to as hot compiling or hot loading. And you can actually compile directly through the editor, which is why in like one of the first lessons I said that you could do that. And now if we look here, we actually can change that variable again, test variable, and we can set test variable again because we changed those uProperty specifiers in our header file. So let's talk about live coding or hot reload. So this is a feature that's built into Unreal Engine 5, and it allows you to make changes to your C++ code in your Visual Studio or your IDE, and then you can, without having to close Unreal Engine and reopen it, you can see those changes very quickly. So it's a powerful tool, right? You saw like how many times I was having to close Unreal Engine, make a change, reopen Unreal Engine, see that change. If you were trying to troubleshoot something, it would be painful. It would take you, like, it would exponentially increase the amount of time it took you to do something. So hot reloading is a very powerful tool. There's lots of reasons why you would want to do it, especially if you're trying to like troubleshoot something, things aren't working, you want to make like incremental changes and see how it works. So the speed is obviously a benefit. It quickly compiles. You can test changes without needing to restart Unreal Editor. It's efficiency, so you reduce your downtime. You can compile, see the changes almost immediately. Not as quick as like the Blueprint compiling. Like this compiling happens almost instantly, right? So it did still, let's save all. It did still take like, what? Oh, it's already done because there was no change. But like, depending on how many changes you make, it could still take a while, but it's almost always going to be faster than building through Visual Studio and then relaunching Unreal Engine. So that efficiency is really good. Iterative development, so you can make small changes and see the result, which is really useful if you're doing gameplay programming or if you're doing like a rapid prototype and you just want to like see things really quickly and then see the update. Limitations. The initial compile time. So like I said, if you make a lot of changes to your header file or your CPP file, that compile is still going to take a decent amount of time. Changes that require full rebuilds. So there are some changes, and it kind of talks about global state, where the hot reloading will actually fail. And you'll get this little beautiful green message that we were getting here that says successful. It's going to be red, and then you're going to know immediately that something is wrong. So you may get one of those errors, and that basically means like, hey, something didn't work. You gotta recompile it manually, basically. And then stability is a limitation. So I'll give you some tips, but like using hot reload is you actually could end up breaking things in a way that takes some time to recover. So I already showed you how to do it. So let's talk about my tips. These are my own personal hints. So if the compile fails, you're going to want to read the output log. So if you're using hot reloading, this is going to tell you some information about what happened. If you're manually compiling, these build files down here are going to give you some information. So if it says build failed in either place, the first tip is to read the output log, because it's probably going to tell you what's wrong. Matter of fact, in a lot of cases, it's going to even tell you like the line of code where the error is. If you compile and it fails, what I usually do, just compile again. See if the errors change, see if something changes, see if the error just goes away. Like, this is almost always what I do. It almost never works, but there are cases where I've compiled and it failed, and then I compile again, and then it passes the second time. Search for a solution online. A lot of times if you take that error that it gives you and you paste it somewhere like ChatGPT or Google or basically anywhere, even that GitHub Copilot, you can just like highlight it and say like what's happening and it'll tell you. So search for a solution online. So I'll show you these last few things, but ultimately my tip is use live coding sparingly. Most of the time, if I run into an issue, it's caused by live coding. It's caused by that hot compile. So I don't use it that often. I only use it if it's like, if I'm like really making like some small change and I want to see the impact of it. But most of the time, I'm going to close Unreal Engine. I'm going to rebuild from Visual Studio, and then I'm going to reopen Unreal Engine. So I'm going to show you these things: clean a solution, rebuild solution, and then create a new SLN file. So the first one, and let's close Unreal Engine for this, is clean solution. So if we go to build, we can see we have some other options up here. So if you do run into an issue where you're having compilation errors, a lot of times specifically it's going to be ones that like refer to like some config file or something. You can always go to clean solution, and essentially what this is going to do is all of kind of like the background stuff that's happening, it's going to like refresh everything. So it's going to delete all the configuration files and like rebuild everything. And we can see here 49 succeeded, 0 failed, 1 was skipped. There's also rebuild solutions, so we can do that one and just show you. It's going to do some of the same stuff. I think clean solution is technically a little bit more, or maybe it's the other way. Maybe rebuild does a little bit more. We can see 1 failed for some reason. So that's that. Now, if you still have errors, there's something that is kind of like, I do this fairly often. So let's close. Didn't I already close that? Let's go to my Unreal Engine file. And we can see here that we have this .sln file. This is actually the Visual Studio file. So we can highlight this and we can delete it. But there's also some other files in here. And if you notice, like if we go to our git ignore, notice that there's this binaries and plugins binaries. There's the build files, there's the saved files, and then there's the intermediate also. Not sure why oh, here we are, intermediate. So these are files that are built when you launch the game or when you do the build through Visual Studio. But these are not files that like should necessarily be passed to another person's machine. Matter of fact, if you forget to put these in the git ignore and you're using Visual Studio, if someone else opens up the project from your GitHub and those files are not in your git ignore, it's going to mess up like all the settings in their Unreal Engine. It's basically like going to set it up as if you're working like from another computer and you want everything exactly the same. So what I usually do is grab this binaries, grab this intermediate, grab the saved, grab the build if it's there. If you do a build of your game, there will be a build folder, and then the SLN file. I'm going to select delete, and I'm going to delete all of those. And then I'm going to right click. If you're using Windows 11, this menu might not show up. You'll have to go to like show more options or something like that. I have that disabled because it annoys me. And then you see this generate Visual Studio project files. So if I select this, it's going to remake those folders. So you can see my intermediate and saved is there again. And then it created a SLN file, and I can open this. And because it's basically like starting from scratch, it's going to take a little bit longer. But notice now, also like when you think it's loaded, it's actually not. I always wait for this output message that's going to come when everything's loaded up. Visual Studio is also like a it's a bigger program than you think. If I go to my task manager, yeah, look at that. It's a hog. This is another reason, like if you have like kind of a weaker computer, not as powerful, like this one's getting old, so it's you may want to use VS Code because Visual Studio is a little bit more heavyweight. But in most cases, most computers can run this. Yeah, so we get these little output messages that basically say like everything's loaded up. Notice that there is no binaries folder, but if I go and do a build, which again is going to take a little bit longer because we just delete all that stuff. So the first build after you like delete everything and restart is going to do a little bit longer because it's kind of building everything from scratch. But notice now we have this binaries folder. So this is kind of, I don't know enough about it. I'm not like a professional programmer. If you go in here though, like this stuff doesn't make any sense. But it's essentially like some computer files that tell it how to run Unreal Engine. So yeah, it's gonna build that, and then then the project should work. So if you have errors, again, the point that I was making was use the clean solution, rebuild solution, generate a new SLN file, and that should reset you. But ultimately, use live coding sparingly. That's kind of my last hint. All right, that's the end of that lesson. We're doing pretty well. Already halfway through. I do think that I'm going to take a quick 5 minutes, get some fresh water, and then I'll be back. So I will be back in just a couple minutes. All right. Got a fresh water, stood up, moved around a little bit, ready to tackle the rest of this stream. So we already talked about a lot of this. I'll just go through this really quickly. We're just going to make a health potion from C++ class, and then we'll show how to make a blueprint from that class. We've already done this, but I just want to make sure that we actually do it for our game. You see that our build finished here. So I'm going to go ahead and open up our game. And I don't need this anymore. Go ahead and delete this blueprint. And let's make a new C++ class that's called Health Potion. I want this to be an actor, and I'm just going to call this Health Potion. And I'll make sure it's a public. And I'm going to say create class. And there we go. And now we should be able to access it. So when we go back to our Visual Studio, because it was still open, it's going to say there's been a modification. Do you want to reload? I'm going to say reload all. And now we see that we have our health potion at 8.h and health potion.cpp. So one of the things I think we're going to want on a health potion, and we'll set this under the public, is I'm going to declare a new U property of edit anywhere blueprint read write. I don't really like the categories unless I'm doing something pretty big. I'm going to declare this as an int 32, and sure. Thanks GitHub Copilot. So now we've declared a U property of edit anywhere, which means we can edit it in blueprints, has blueprint read write, which means we can read from it and set it. And then we have named it health amount. And then in my constructor, I'm going to say health amount equals 50. And notice I don't have to declare the variable type when I'm doing this because it's already been declared in my header file. It knows that it's a integer, basically. So let's go ahead and save this, and I'm going to do a build. Failed, huh? Oh. I think that was because Unreal Engine was still open. Yep, there we go. Now we're good. Let's go ahead and launch our project again. all this quiet without music. All right, so let's make a new blueprint class. It's going to be of type health potion. Select, and we'll call this BP health potion. Let's drag one in. And then right here, we can open this up. Let's dock it. And we can see we have that health amount as a default variable. We can also, so the next thing I want to do is right now, if I press play, it's here, but I can't see it. So I want to be able to have like a static mesh component, but I don't want it to be in blueprints. I want it to be declared in C++. So I'm going to save all. I'm going to close this, and I'm actually going to declare that this health potion will always have a mesh. And I'll do that here. I'm going to declare a new U property. Thanks, Unreal Engine. And I want this to be a static mesh component. So I'm going to declare a U property, edit anywhere, blueprint read write, and it's going to be a class this time. And that's because this U static mesh component is actually a class. The variable type is going to be called mesh. And we'll notice this one has this like weird star thing. And what is that? Well, this is called a pointer. And what it basically does is it says, I want you to point to another file, and I want you to use the information from that. So in order to do this, we actually need to include the file that it should look at to get information about this static mesh component. So we can do our first new include. And this is going to be components slash static mesh component. And I want to include a comment. So you can comment by doing a double slash and then typing a comment. Comments are not read by the compiler. The compiler will ignore them. So you can include, you can see here we have some comments about this. They basically allow you to include some information. Why? All right, let's try to build this. This should work. Failed. Oh, .h. That worked. All right. So now we have a variable that's of type static mesh component on our health potion, but we won't actually be able to set it as anything yet because we need to set it up in our constructor, because the constructor is going to set like a default value for it. So we can do mesh, because that's what we called it. And thank you, GitHub Copilot. Probably should have disabled it if I'm doing an introduction lesson. But we have our mesh equals create default sub-object, use static mesh component, and the text, meaning what are we going to call this in the Unreal Engine editor, just going to be mesh. So now if I save and build, succeeded. So let's launch our game again. And I think like another tip for hot compiling is usually if I'm making changes to the header file, I'm not going to use hot compile. Like that's kind of like the most basic way I put it basically. But while that's launching, we can kind of talk a little bit more about this. So the U static mesh component is its own class. If you hold Control and click on it, it'll actually open up static mesh component.h. And we can see that this is like its own class. Like the static mesh component that we can put on an actor is its own C++ class. And here we can have some information. We can see some information about this. We can go through all this. Like there's a lot here. Like, is it available for Nanite? Notice like when I open my health component, like now we can see that we have this mesh here in our editor and it's called mesh. And see all these variables over here that we would normally see in the details panel. Again, because the details and this my blueprint is essentially the header file. All the information about the static mesh component is available here in this header, in the header file for that. So like, let's try to find one. These are all public. So selected header. Let's find one. Wireframe color. You could probably find that somewhere in here. Wireframe color, see? So yeah, essentially everything that's in your details panel is going to be in your header file. So if you wanted to make a change to the uStaticMesh component.h and make it a change for all actors in your game that use the uStaticMesh component, you could technically make a change to this file and change the way everything in your game interacted. Again, I don't really recommend that unless you really know what you're doing, but you have now access to like under the hood to like change the way, fundamentally change the way the Unreal Engine works. So that's that. But notice that in our health potion, we declared this static mesh component. We declare it as a class called static mesh component because it is a class. And we included the star, which means it's a pointer. We want to point to that file, which is why we had to do the include of static mesh component. We named the static mesh component mesh. And then in our health potion.cpp, we declared a default subobject set of uStatic mesh component. So this is how we would declare that. These like less than or equal to signs, these are containing the name of a class. You'll see these in like various things throughout Unreal Engine and C++. So there's a function on uStatic mesh component called create default subject, or is this may be somewhere else. This is in uObject, sorry. So uObject.h has a function called create default subobject. And then in that you can declare a object type because uStatic mesh component, let's go up to the top here. Just want to go to the top, man. There we go. Yeah, there's a lot going on here. I don't want to get too off the rails, but essentially we can keep drilling under. So use static mesh component is of type it inherits. So this means class use static mesh component inherits from uMesh component. We can go to uMesh component, which is a class called uMesh component, which inherits from uPrimitive component. uPrimitive component inherits from uScene component. And these are some interfaces. This is how you declare an interface. uScene component navigating to definition. Oh my goodness, must be really buried. But anyway, now you can like really get under the hood. So all of this is just to kind of explain like how what a pointer is and how it works. So we want to create a variable of type of another class. So we need to use a pointer that points to where that class exists in the engine, which is here in this header file. And now we have access to use that in this class, and it's here. So we can actually now set a static mesh. Let's just make this one. I like to use the cone because it kind of sticks out. And let's make this cone gold. So my health potion is a gold cone. And now we can see there's my health potion in the world. And in here, I can actually make changes to that. So like I can say like mesh this arrow thing, and then I can say set collision enabled, and I can say that this mesh, I want no collision on it, so I want it to be able to be walked through. So let's use hot compile for this, because this is a perfect time to use it, because we didn't change the header file, we just changed the CPP, and it should work, hopefully. Don't make a fool of me. Perfect. So now I can walk through it. Now it mesh, no collision. Build. Yeah, I think I broke it. I don't know why that didn't work. But anyway, it should have worked. Let's close you. Let's build again, and then we'll reopen it. Perfect, now it worked. This is what I was trying to say about the hot reload, hot compiling, live coding, whatever it's called. It's tedious and painful. It annoys me. So while that's loading, let's talk about this. Set collision enabled. This is a collision channel. So if we hold control and click on this, and here we could see these are all the different types. So no collision, query only, physics only, probe only. Query only is see if I can walk through this thing now. Yeah. There we go. No collision. We can then change that on this class. So the default value is going to be set in the C++, and then we can change it here. So see here, collision, no collision. We can then change it to block all. Press play, Now it should, yeah, now we can't walk through it. We can also change it to overlap all. And now we can have access to the overlap function. So let's just show how that's going to work. Let's file, save all. Let's close this. I don't want to change that. Let's get rid of this. And let's declare our first function. So I'm going to go to here. I'm going to go into the public section. And I want to declare a U function. I want it to be blueprint callable, so I can call it from the function. And I'm going to, I don't want to declare any return value, so you use void. Void says this isn't going to return anything. If you wanted it to return something, we can set up like int 32. Get like a getter would usually have that because you want to call get health amount and then you want to return health amount. So that's, you can do that. So let's set up as a void. And I'm just going to call this test function. So now we've declared a new U function that is going to be blueprint callable. It's got a return type of void, which means it doesn't return anything, and it's called test function. And notice this green squiggly line. This is giving us a hint, and it's saying function definition for test function not found, which means the function exists, but we don't know what to do with it yet. So we can, this little screwdriver will say create definition. And so if I click that, now notice that we have a new function declared over here, and it says it's a type void, it's a return type void, and it's a health potion, which means the class that we want to call it on, : test function with parentheses. Remember, if we want to pass in a variable, it goes in here, and then here is where we will, actually that's exactly what I want to do. I gotta say, this GitHub Copilot is pretty awesome. And then in these brackets is going to be any functionality of this function. So we have, this is essentially the same as a print string. It's a UE log. It actually prints to the Unreal Engine log, which I'll show you how to get that if you're not sure. And then we have a few things. If we hover over this, it gives us some information on how this macro works. So it says that logs a formatted message in the log category and is at the requested verbosity level. And then it has log temp, which is, if we hover over this, it says temporary log category. All right. And then this is the, come on, IntelliSense. This is the importance of the message. So warning is like fairly important. I think error or something like that. You can see here. Category name. Verbosity is the name of the log category. Verbosity is the level. CE log verbosity. And then format is the string. So let's go back here. So essentially what this is it's going to log something to the UE log. And what is it going to log? It's going to log this text. So you can put whatever text you want in here. So it's going to say health potion test function. So let's save all. Let's compile. And let's open our project again. you can see why I don't use C++. Typically, it is painfully slow when you're just starting to, like, if you already know what you want, and we'll talk about this more next week, it's actually great. But when you're like just like tooling around and trying to figure out what you want things to do, I typically don't recommend starting in C++, especially when you're first beginning, because it's just so tedious to go back and forth. Like, I'll show you in week 7 kind of my method that I use, and then it helps streamline things a little bit. But for the most part, if you're kind of like trying to figure out what you want something to do, C++ can just be a little bit slow. Usually Blueprints is better for like prototyping something, figuring out the basic functionality, and then you can kind of go for there. So what I actually want to do is I want to show, if we overlap the mesh, I want to call test function. So now see, test function is something we declared on that header file and in the C++. So we say test function, and because we made it blueprint callable, we can actually call it in our blueprint. And so essentially right now, when we overlap with our health potion, we're going to call test function on health potion, which is going to call this function, which is going to just print something to the log. So let's see how that works. Let's go ahead and press play. And I'm going to open this and open up my output log, so you can see kind of in the background what's happening. And when, let's do this. This will be better. I want to have you stay window output log. There we go. That should work. All right, when I overlap this, you can see that it printed something. You can't really see it, I guess. But it did print health potion test function. We can also have it do a print string and get that health amount. And so we are going to print to the UE log and print the health amount, and we saw that it printed. We can also see that print string here, 50, and it printed health function test function. So we now know that our health potion is set up. If you wanted to, we'll do this because we're gonna do a couple more things, but if we have a health component on our actor and we want to like use this health potion, like if we walked over it and we wanted to refill some health, we can have those classes talk to each other. We'll end up doing that by the end of this week, but let's for now, I think that's everything we need to do for this lesson. Yeah, let's go to the next lesson. And this one is going to be C++ interfaces. We've talked about interfaces before. We made some blueprint interfaces. Before we set up an interface that we used in our firefighting game, our fire escape game, where we use it to check if something was interactable. So you can also declare C++ interfaces, and you'd be surprised, it's pretty much the same. Like there's not that much different from it. It's a little bit complex. So if this gets like too complex for you, you can always skip this, do it in blueprints the way that we already knew how to do it. But I don't think it's so complex that like you can't like slowly grasp it. So we'll try to go slow and get through it. But essentially we're going to describe interfaces in C++. We're going to demonstrate creating an interface in C++, and then we'll demonstrate implementing a C++ interface. So a C++ interface is essentially a class with no variables or function implementation. They can only contain pure virtual functions. Now, when we talk about a pure function, we should already kind of know what that does. It's a function that just passes. It doesn't change any state of the game. It can take information in, process that information, and provide an output, but it can't change like the state of anything. A virtual function is a function that can be overwritten, and we could see why this would be important with an interface, because the whole point of an interface is to create like a common connection point to actors that have like a similar function, a similar implementation, but different functionality based upon that implementation. So in week 2 or 3, we used this to set up, we used an interface to set up an interact component. So when you interact with things, you want them to have different functionality. If we interact with an item, we may want to pick it up and have it go into an inventory. If we interact with a door, we may want to have the ability to open the door. If we interact with a light switch, we may want the ability to change the light switch, but we want all of those to have a similar functionality called interact. So we can do the same thing in C++. We can create a common connection point for multiple actors, and then they can inherit that interface. They have access to the function that we declare on that interface, but every actor that implements it is going to be a little bit different. So let's, and we can see here how it works is we declare as a U interface. It's still going to be a class. You're going to call the name of our interface, and then it'll just have functions, but it'll create a CPP file, but we don't actually use it for anything. We're just going to be changing the header file. And then the way that we implement an interface is in the class. After we declare the name of the actor, we declare any interfaces. So you can see that it's showing up here, and then we can override, we'll call virtual override to override that function on the class. So it's great. Enough talking about it, let's do it. So I'm going to create a new interface. I'm going to create a new C++ interface. So let's go to Tools, new C++ class, and I want to, I don't know if it'll show up as one of the common ones. Unreal interface, it did, great. And I want to call this interactable, because I want to essentially do the same thing we did before. I want to create an interactable interface that we can put on any actor that we want to be able to interact with. And I want it to be public, so we'll go ahead and create this class. All right, I'm going to close Unreal Engine. And let's go to our project. We'll go reload all, and we can see now that we have our I don't know how to spell. Interable is what I wrote, not interactable. We can see we have the CPP file, but look, it's empty. Like, you can put functionality here, but I'm not going to. And then we have our header file, interactable is what it should be. And we could see that it's declared as a U interface, has this normal stuff, and then down here we can add a function. I'm gonna, oh man, virtual void, and let's call it start interact. All right. And notice that it's giving me like this thing where it says like, do you want to make a definition for this function? We don't actually want to. So there's a way that we can basically tell it, we want this to be a callable function, but we don't actually want it to do anything on this class. And we do that by just putting some curly braces. So now we have virtual void start interact parentheses and then curly brackets that basically tell it this is a function, but there's no implementation for this class. It's just, we're just declaring that it exists. If you did want to do something with start interact where every interactable object would do something like, I don't know, let's say for instance, you wanted it to like pass the owner. I'm just trying to think of something. You wanted it to like pass in the owner of it through the interface. You could declare like the owner, set it up, and then have it pass it, but we're not going to do that. But in that case, you would need to declare the owner probably in the CPP file. I'm just trying to think out of the box here. But for this interface, we're just going to set up this way. All right, now on my health potion, I can actually implement this interface on my health potion. And the way I'm going to do that is I'm going to have to do two things. The first thing is I need to include interactable. Thank you, GitHub Copilot. And then, oh man, this thing is great. I probably should have disabled it for these lessons because I feel like I'm cheating a little bit. So the way we do it is we need to include the header file for our interface. And then after this is being declared, health potion, which is an A actor, we declare that it has the interactable interface. And then down on our public section, we can declare virtual void start interact override. And we can declare a definition for this. Well, for now, we'll just set up with some basic stuff. All right. Yeah. So there's that. And that's basically how you implement an interface through C++. So just to kind of review, we created a new interactable interface called interable. And then in this interface, we just declared a public function that's virtual void start interact. We included the curly braces to say on this class, this does not have any implementation. Then on our health potion, we included the interable header file. We added this interface by using a comma after the name of the health potion, and then put the interable interface. And then we declared virtual void start interact override to override the function for this class so that this class can have its own functionality for start interact. And then here we're just implementing that start interact function with some basic text. So it's just going to do a log for now. We'll do more as we continue to build, but for now, this is all we want to do. And I think that's the end of this lesson. Yeah, great. So In week 2, maybe, we talked about event dispatchers, and I think we've used these a few times so far. In C++, they're called delegates, and that's what this lesson is going to be about. And then the last little bit, we're going to pull it all together. So in this lesson, we'll describe delegates using C++. We'll demonstrate creating a delegate using C++, and then we'll demonstrate the implementation of a delegate. So if we remember, an event dispatcher, we learned, was a way to like broadcast a one-way message out into the world. A delegate is the same thing. So it's the method for broadcasting information to be used by another class. It's a one-way communication. So we send the message and we never get a response whether it was received. The sending class just actually doesn't even care if it was received at all. So the difference is with event dispatchers, everything's just an event dispatcher. With delegates, there are different types. There's single, multicast, dynamic, and then there's like mixtures of these as well. You can read the documentation on this. Actually, that Ben UI guy, I think he has some pretty good documentation on this as well. But essentially, the one that we're going to use that's most similar to an event dispatcher is the declare dynamic multicast delegate. This is what we'll use for this lesson. So let's create a delegate. And actually, let's create it on our health potions. So the way we declare delegates is we want to declare them at the top up here. So we're going to say declare, what was the one we were using? Dynamic. And these are typically going to be prefixed by like an F. So we are going to create F on interact. And the way we, hang on a second, I'm just going to check on something on my cheat sheet. All right, I guess I don't have it. Oh, I think it's on this one. Yes. All right. So we now have this delegate, but if we want it to be able to be used in blueprints, there's something else we got to do. So here in my public section, I'm going to create a new U property. Blueprint assignable is what I want. GitHub Copilot, you're my hero. Let's just give that a second to catch up. Oh man, I think you guys could see that. So yeah, don't know why this is taking so long. Save. I'm going to try to do a build. Sometimes doing a build will like clear up these squigglies. All right. There we go. Finally caught up. All right. So we have our delegate. It's called F on interact. So this is declaring a delegate on this class. And then if we want to use it in blueprints, we're going to use a U property, and the type is going to be of the delegate that we declared, and then we want to declare the actual on interact. So let's and then the last thing I need to do is let's actually do this. I really should disable GitHub Copilot. So now on interact, which is our delegate that we declared here, the broadcast is the same as call. So when we use an event dispatcher, we call an event dispatcher, which is what sends the message out into the world. With a delegate, it's broadcast, which actually to me makes more sense than call. Like call, I think of like calling someone to me. Broadcasting is like sending in information out. So here we are going to broadcast this message into the world. And yeah, that's that. So that's how we use a delegate in our game. Let's do a build. And in a future lesson, I think we'll listen for this. But for right now, I think that closes it out. Everything looks good. So that's delegates. I feel like the way I'm going through this I feel like I need to revise this for future courses. Feels a little bit everywhere. So let's go through the next lesson, which I think is we're going to start pulling all this stuff together. So what we wanted to do was basically like talk through some of the C++ concepts that we've already kind of learned about in blueprints, but now we want to pull it all together. So now we're actually going to create a health component that we can implement onto our player. And we've already done this in blueprints. So essentially we're taking knowledge we already have, and we're taking all the tools that we just learned, and we're going to pull them all together, and we're going to create a C++ health component. And we want essentially the health potion to refill some health when we overlap it. So that's kind of what we've been working towards. So let's open up our project. And for this lesson, really all we're going to do, we're going to create a C++ health component that we can attach to our character. And then we want that when we overlap with that health potion, it refills some health on our character so that we can show how these two C++ actors can interface with each other. So let's create a new C++ class. Let's create an actor component. We don't already have one, do we? No. And this is going to be called player. Let's call it character health. Because we may want to use this on other characters, basically. So let's create class. So up until this point, we've just been learning about like some principles of C++. Everything up until this point, like if you've been following along, we're just like showing how things work. So hopefully you kind of learned a little bit about these things, but now we're actually going to be creating something. So let's reload. And interable, I really want to fix that name, but I'm kind of being all right. So what do we need in a health component? We've already done this in blueprints, but what are some of the things we need? So we need some variables, right? So let's declare some U properties. U property. Let's do an int 32 max health. and U property. Why does it always do that? Love and GitHub Copilot. So we now have two properties, int 32 max health, int 32 current health. Let's set this one to 0. And then we want to create a function. I don't know why it creates this down here. But anyway, maybe it's trying to keep functions and variables separate. I don't know. Let's create a U function. God. Called take damage. So we have a, and then we want in our constructor, so we've declared the base value of max health. Let's here on begin play, let's current health equals max health. So whenever the player starts the game, they're just going to set their current health to max health. And then if the character, if we call take damage, it's going to pass in a damage amount. And then we'll take damage amount and subtract that from current health. This minus equals is essentially like subtracting the variable and then setting it. So we're taking current health, subtracting damage. It essentially does the same as this. Current health equals current health minus damage amount. So these basically do the same thing, just a little bit easier to do it that way. So we have take damage. If current health, we're going to take this damage amount that we pass in, subtract it from current health, and then we want to check if the player is dead. So let's file, save all. Let's build this. Everything should work. Yeah. Let's launch our game. Let's open up our player character, and I want to add that health component. So I'm going to add character health, and we can see that we have access to those values here because we set them up that way. If we wanted to, like current health, maybe we don't need to have the ability to set it. We could change that variable type so that the U property settings. Notice also here we have this begin play and then parent begin play. I'm not sure if we've seen that yet, but oh, because begin play character. Yeah. All right. So let's open up our health potion. And I'm just going to create like a test actor as a blueprint. I'm going to call this damage volume. I want to be able to damage the player. So let's add a static mesh, cylinder. All right, let's sure, that looks good. And when we overlap this, let's just set up some just setting up the ability to just test this. So if it does, then we will take damage. And we want to take 50 damage. I'm just going to set up basic UI really quick. Folder, UI. Nope. Get player character, cast to player character. Player. And then here I can just bind this to sorry, That was a lot of work to just get to the point where where's my HUD? Weird. Oh, is it because I'm not even using that? I think that's the problem. You're useless to me. Actually, you know what? Let's do it that way. I changed my mind. We should have been doing this all along. So in my game mode, I want to use player character. Now this should work. Text. Yep. All right. Sorry. All right. 100 out of 100. 50 out of 100. Okay. Damage volume. Take damage. Take damage. wonder why that's... But I can overlap with this one. It's like something wrong with this. I don't get it. I really don't get it. Wacky. All right. You are done. I don't know what happened to you. I don't know who hurt you. Done. Let's go to here. Goodness gracious. All right, I'm dead. Look, it worked. It worked. All right, I do know what I'm doing. There was something wrong with that actor. That was so strange. All right, so we can call this take damage function. We passed in the amount of damage here. It's 50, and we took damage. So we saw that. I'll show it again. My health is 100, and now it's 50, and now it's... And we can even go lower because there's no clamping. So if we want to do that, you need, oh God, math something. It's like math. Clamp. I have it. I just gotta find it. F math. Goodness gracious. All right, so current health, clamp it between current, and we want to, what do we want to set it to? So this will tell you like current health minus damage amount, we clamp it between 0 and max health. So let's save that. Let's try to hot compile because we're feeling a lucky. Look at that, we did it. All right, so now when I overlap with that cube, we should not be able to go below 0 health. Perfect, it worked. All right, so we have a health component. We also now on our health potion could do the same thing essentially. Get component by class, health is valid. Take damage. And then we can get health amount. And we could do it times -1 to make it a negative. And then if we pass in a negative value to this, it'll refill the health. So this little box is going to take health. This little thing is going to refill health. So now we have a working health component. All right. Hopefully that makes sense. But I also want to show like this. We could migrate all of this to C++. It's a little bit more involved. Maybe we could show that. We'll actually show it next week when we're doing a little bit more complex things. But for right now, I just want to like keep the level of C++ to like a basic level. Because I don't want to be, I want you to still be able to like draw from your knowledge of blueprints. So we've only written like what, maybe 20 lines of code. But yeah, so we now have this health potion that can refill health. We have this test actor, which can take damage the player. We have our player character, which has this character health component, and all of that's working. So let's save all. And the last thing we need to do for the week is create an interact component, which again is something we've done in blueprints, but not C++. So we're just going to implement an interact system using C++. So let's, we already have that interactable interface that we can put on actors. But we need an interact. I mean, I guess you don't need it, but I'm going to create an interact component. And what that'll allow me to do is put the component just places that I want it to be used. And then we could put it just on our player character. And then the player character would have that component that they could use to interact with things. So let's start by creating a new actor component. Let's go to tools, new C++ class. Let's create actor component. And let's call this interact and create class. And we're almost to the end of the week. So everything worked well. Still running. All right. Good. Let's close out this. Let's reload here. And I don't need this character health anymore. We want our interact, CPP, and H, and I think this is what we want. So let's go ahead. I'm gonna look at my cheat sheet. All right. So we have this interact component now that we can use, and we want to do, if you remember when we did this in Blueprints, how we did it is we had it sending out a line trace, and it's going to be checking if something has the interactable interface, and if it does, it's going to set it to an interacting actor. So those are kind of like the three things that we want to do. So I'm just going to create some notes here, and a lot of times when I kind of know that there's going to be a lot of things that I need to do, I will use comments to create notes. So the first thing we want to do is we want to create a line trace that checks if the player is looking at an interactable object. Thank you. Then we want to, if the player is looking at an interactable object, we want to set it as the interacting actor. So this means we need an interacting actor, and I think that's all we need to do. So the first thing I want to do is set up some variables. So I need an interacting actor. So let's set up a new uProperty. And it's going to be of type object pointer. Look at that. So this object, this variable type, object pointer, if we control click on it, wow, that doesn't give us a lot of information at all. But essentially what this does is it allows us, like in the other class, health potion, when we set up this static mesh component, we had a pointer to this. What this does is it allows us to create a pointer object without having to declare it in our header file, essentially. I think that's my understanding of how it works. So we now have an interacting actor. Let's create a uFunction that is blueprint callable. And this is going to be a void get interacting actor. Let's go ahead and create the implementation of this, even though we're not going to be doing it yet. And then I want to create one more function, uFunction void interact. All right, and we will do that. So we have get interacting actor and interact. And there's one more thing that I want to do, and that is that when in the when we did this in Blueprints, we implemented it on the character, and the character already had a camera. But because this is a actor component, we actually want to use whatever camera is already on that actor. So I also want to create another variable called uProperty. And this one's going to be a little weird. It's going to be of type uCamera component. I don't want your help. There we go. uCamera component, camera. But in order to do this, I need the include file of include, there we go, camera/camera component.h. So now I'll be able to get access to the camera that's on the owning actor of this. So now I have my variables. Let's move this up here. So I have my variables of interacting actor and camera, and I have my functions get interacting actor and interact, and we are ready to start coding this. Just real quick, I'm going to save. All right. So the first thing I want to do is here in my constructor, I'm going to set up those variables that we set. So camera is going to be a null pointer, and this basically says when we start, I want it to set to null. And then interacting actor, I also want it to be set to a null pointer so that when we start the game, the interacting actor is in fact null. Why is that? False. All right. Let's try to do a build. See if we're getting any build errors. Failed. It's that. Oh. T object pointer. Not T is T object pointer. So T object pointer, a actor, interacting actor. Now we should not get any build errors. Good. All right. Great. So let's one of the things we want is on this one, we are going to be wanting this tick. So, and it's what we want to do is on every tick, we want to call get interacting actor. So every single frame, we're going to be calling this function. And then that way we can program the functionality of this function. Separately. So, oh man, come on. Can't cheat that bad. All right, so let's set up a few things. We want an F hit result called hit result. We want an F vector called start location. This is really cheating. I feel like I'm cheating. We want another X vector and location. And then we want an F vector. Oh. I'm going to call this forward vector. And location equals start location plus end plus forward vector. So essentially this is setting up all the variables so that we can use them in our hit result. And the way the hit result works is we'll do if get world. I'm gonna try to type this. If get world line trace single by channel hit result, comma, start location. Yep, this is what I want. Jeez Louise, man. Identifier hit result, unidentified. There we go. All right. So essentially what we've done here is the line trace single by channel exists in this U actor component get world. So we want to say, this is essentially saying like, we want to send a line out into the world, and if it hits something, then we want to get the actor that it hit. And if it doesn't hit anything, then set the interacting actor to null pointer. And the inputs of this are hit result, which we declared up here, start location, which is the camera get component location, end location is start location plus camera plus no. Yeah. No, this is just camera get forward location times 1,000. I think 700 is probably better. This is going to be the length of that line that we send out into the world. And then the end location is start vector plus forward vector. We did this in blueprints. It's just a little bit different when you look at it in C++. But then this is the line trace here. The ECC visibility is the channel that we want to interact with. So we want to use the visibility channel. If the line trace interacts with something, we want to get the hit result, which is here, dot get actor, which is one of the, if we click on this, is it loading? Anyway, so the interacting actor will be whatever we interact with, and if not, then it'll be a null pointer. So that's that. So that's our get interacting actor. Now the interact is where we're actually going to interact. So if interable. Let's put that in the header file. Hashtag include interable. I spelled it wrong, but now I know when I'm finding it. If interable star interact interface equals cast interable actor interface start interact. All right. We're getting there. We're almost done, actually. Like it's pretty much done. All right. So, and I think that's it for this. Yes. All right. So let's just talk through what all this is. So this is an interact component that we can put on any actor, and it has two variables: the interacting actor, which is a T object pointer to a actor. Again, this allows us to set a variable without needing to do the include. It's going to go look for it. We have a uCamera component of camera, which we're going to be able to set here. We have a function called getInteractingActor, and we have a function called interact. We on our tick, we are going to call getInteractingActor, which every frame is going to set up all these variables to basically get where the camera is and a line into space, 700 units. It's going to set that as the end location, and then if that line interacts with something, we'll get whatever it interacts with and set it as interacting actor. If it doesn't interact with anything, then we'll set it to null, which means when we call interact, it will not do anything, and that's down here. So we're going to call this interact function. I'll set it up for like a key in Blueprints, and then we're going to basically say if the interacting actor has the interact interface, that's what this basically means right here. So if interacting actor, which we set up here, has the interable, not interactable, interface, then we want to set that as a variable called interact interface, and then on interact interface we can call start interact. So all this is to say we've essentially created a C++ interact interface that is going to be identical to the one we created in the week 2. So let's save all. Let's do the last step of this, and hopefully it all works. If it does, that's all we had for today. All right, so that compiled correctly. Let's open our game back up. I gotta figure out this music thing. So much dead space. All right, so. No. In my blueprints, I want to find my, actually the first thing I want to do is get my input folder. Where is this at? Game third person input. So let's create a new input action called interact. So input action, IA, interact. I'm gonna just set this as a pressed, and then my IMC. I'm going to map this to E. I like E. Some people like F. File, save all. All right, now on my character, all right. Oh, we got to add our interact component, and then on here I can call interact and now when I press E I can interact with something. So let's go back. Let's save all this just in case we break something. Let's go to our health potion. And I want to, in here, let's leave that there for now. Can't remember how I did this. All right. Anyway, let's there's like a way to I know how to do this. I just can't remember. Anyway, start interact. Start interact. Start interact. I think there's an issue with doing this. This is going to cause a compile error. I don't want to get stuck on this. For now, let's do this. I'm just going to do some text up here. And I want to bind it to the player interacting. Oh, that broke my All right. I think we're wrapping up. It's like right around that 3-hour mark, I start to hit my wall. Going forward, when I do these streams, I'm going to only do 3 hours. I feel like that's my wall. All right, let's see what happened here. Nope, it's doing something wrong. All right, we did cover a lot today. I just don't want to like lose sight of everything we did. So I think I'll do a quick review. Because I definitely can feel myself starting to lose patience, let's call it. Let's do this. No, that crashed it too. You know what you can do if this keeps happening? You can run it in debugger and it will tell you why it's crashing. That's what I'm going to do. Instead of just keeping doing the same thing over and over again. Why did it open twice? All right, so I broke something. I wonder if I delete this. Nope. All right, something's broken. I'll figure it out. I'm going to end the stream though. I just want to review really quick because we did cover a lot today. It has been a fairly long stream. I'll get this fixed. We'll talk about it in the next stream, which is going to be next week. So, you son of a, yeah, there's something I broke, but we're not going to talk about that. So today we did a quick introduction to C++. We talked about IDEs and what that is, the integrated development environment. We installed Visual Studio Community 2022 so we could use it to do some code editing. We talked about what is the differences, how do you break down what a C++ function is. We talked about how to set pass in input variables, how to return a variable. We talked about all that in functions. We talked about the header file. We talked about U properties and U functions and how to set those up so you could use those in your classes. We talked about how to compile and build projects using VS Studio, and we also talked about VS Community. We talked about hot reloading and how that can save you some time, but there are some considerations you should take, and don't overuse it. We talked about how to create a C++ class and then how to create a blueprint class from that could inherit from that C++ class. We talked about interfaces and delegates. Didn't really get around to using them because I broke something. And then we used all of that knowledge to set up a C++ health component and a C++ interact system. So a lot of stuff we covered today. If you've been tuning into the course, it is getting close to the end. These weeks I've had a little bit less time to prepare, so I think they're getting a little bit rough. I acknowledge this, and I am doing my best to try to keep it on course, not get too sidetracked. But I think in future iterations, I've learned a lot over the last 6 weeks doing this, and I think the next time we come around, if I do an updated version of this, I've definitely learned a lot of lessons. So I appreciate you sticking with it this far, and hopefully you're still learning from the course. The good thing is next week is going to be a little bit more casual. We're not really going to be learning anything so much. We're more going to be exploring ways that we can set up new components in C++. So we're going to set up a leveling system so that we can gain experience, which is pretty important to an RPG. Having that player progression is really important. We're going to set up some stats so we can have different stats affect things on our character. Things like we're already set up health, but things like strength, stamina, intelligence, intellect that could, strength impacting physical attacks, intellect impacting, magic attacks, but really just setting some foundations that you could use for other components in your classes. And there's one more thing we're going to set up that I can't remember. Leveling, stats. Actually, I think that's it. Oh yeah, we were going to do an inventory system, but I just think I'll run out of time. So I'm not going to plan to do the inventory system next week. If you have been keeping up with the course, hopefully you're learning a lot. It does take a lot of time and energy to create these courses. I do want to continue making them free. I've considered releasing them as paid courses, but I think it's really important to the Unreal Engine community that there's access to free quality resources. But it does take me a lot of time, and I'm trying to keep these free. One way you can help me keep these free is if you do want to book a session with me. I'm offering a 60-minute session. We could talk about mentoring, tutoring. We could talk about setting up your portfolio, how to get a job in the game industry, things that you can improve on for your games. We can go over, some people like to just use this as a way to have one-on-one help to solve problems. Really anything you want, it's there for you. $25. I am considering raising the price of this, so get it while it's still $25 and we can talk. You can scan this QR code, or you can go to jimdouglas.com/book-online. And another way you can help support the community is I have some merch. I have these dev everyday shirts that I had made. So I do get a small portion of the proceeds for that. So if you like the swag that I created, you can buy those, and that helps me as well. Those are ways that you can help strengthen the community and help fund to keep these courses free, essentially. So hopefully you can take advantage of one of those. Like I said, next week we're going to be learning a little bit more C++. We're going to be talking more about how C++ and blueprints really like benefit each other. So I get asked the question a lot, like C++ or blueprints, and it's not so simple. That's not a simple question to answer. So we're going to dig into that next week. I'm going to give you my personal opinion on it. It's different for everybody, but you'll get to hear my thoughts. And then we're going to build out a few components that we can use for our RPG game. And then the last week, really all we're going to be doing is wrapping up everything. We're going to be talking about building our games so that we can release them to the public to do play testing, or even like a final version of the game that you want to release like on Steam or the Epic Store, or even just itch.io. If you even just want to create an executable that you can give to your family, how we can go through that process. So that's the last 2 weeks. We're getting close to the end of the course. So hopefully you're still learning a lot. Hopefully you're still enjoying it. Give me some feedback in the comments if there's anything you want to be done differently. If there's things you're liking, not liking, you can do that. You can also join my Discord, talk to people directly in the community there. But otherwise, I hope you had a good time today, and I'll see you next week, next Friday.